Very good evening to all of you. I welcome all the participants to this AROHAN lecture series 14. Today we have 4 speakers. So first session will be from Dr. Nagaraj B. Patil. He'll be talking on research issues in wireless sensor networks. To introduce Nagaraj Patil, he has been awarded PhD in 2012 and he is having 31 years of teaching experience and 12 years of research experience. His research interest area is computer networks and wireless sensor network. And he has served as lecturer, senior lecturer, and assistant professor and lectured in the Department of CSC at SLM College of Engineering, Raichur, from 1993 to 2010. So from 2010 till today, he is working as associate professor and head of the Department of Computer Science and Engineering at the Government Engineering, Government SKJT Bangalore. And he has totally 14 research publications in various national and international journals, 20 national and international conferences. And he has also guided 7 PhD candidates. And there are some 3 PhD students pursuing PhD. I welcome you, sir. On behalf of all the participants here, I just welcome you and I request you to start the session. Thank you.
Thank you, sir. Right, madam. These are the research issues related to, madam, previous one, related to wireless sensor network. The question will arise, what is network? Network is nothing but a group of nodes connected together to share the information from one node to another node. Wireless means earlier we are using land phone. The land phone is connected by wire. Nowadays everybody is using mobile. The mobile is example for wireless device. Same thing. We are connecting a group of network together using wireless. The main issues related to research issues are quality of service, security issues, energy efficiency, network throughput, performance, ability to cope with node failure, cross-layer optimization, scalability to large scale of deployment, node localization, and last one is heterogeneous, coverage and connectivity in heterogeneous. The quality of service totally depend upon your performance. The performance is totally depend upon your network. The network is consist of a set of nodes. And here, when nodes, so many nodes are present, we are making a group of nodes together. That is possible by using clustering. The main area is in our wireless sensor network is to make the clustering. The clustering consists of a group of nodes. How one node is connected with another node, and all these nodes are connected together, we form a network. And these nodes are connected to cluster head. And from cluster head, we can communicate between node to node or node to cluster, and cluster head transfer the data to your station. The quality of service depend upon your performance. When more nodes are present, the performance is decreases. That depends upon traffic. Indirect, it's saying congestion. Congestion is nothing but when too many nodes are present, automatically the network performance is decreases. It will affect on your performance. The total performance is depend upon network throughput. The network throughput is depend upon how the node is moving from source to destination. When nodes are more, automatically congestion will occur. When congestion will occur, the moving node from source to destination is very complication. That complication, when complication is there, automatically the main area of the wireless sensor network is energy efficiency uses. And whenever sensor node is there, the sensor node is totally depend upon your energy, because we are deploying our sensor. Whenever sensor is having power backup, that is energy. When you are using your sensor more time, the lifetime of the energy will become less. When energy will become less, automatically the node will become dead. When node will become dead, the data transmission from source to destination is very, very difficult. And whenever wireless sensor network is there, we are not having fixed network. When no fixed network is there, and the nodes, when you are making cluster, the moving of nodes from one cluster to another cluster, when we are moving from one cluster to another cluster, it is very difficult to give the security. That is the main issues is security issues. When you go for security issues, suppose one node is at cluster 1, if it is moving to cluster 2, when it is connected to cluster 2, so many nodes are present. When so many nodes are present, automatically it is very difficult. How can we trust our node? Actually, it is in cluster 1. Unfortunately, it is moved to cluster 2. The cluster 2 node, the node which is moving from our cluster to another cluster, when another cluster is there and it is connected to so many nodes, how can we trust? That is the main issue is security issues. These are the first 5, that is quality of service depend upon network throughput. Network throughput is depend upon congestion, and congestion is totally depend upon energy efficiency. When so many nodes are present, suppose we are having 100 nodes. Among the 100 nodes, if 10 nodes are not working due to problem of energy consumption, due to problem of moving off from our cluster to another cluster, and the data, earlier it is moving from data from 100 nodes, it is reduced to 90. Same thing, if we are considering 100 nodes, if 100 nodes are reduced to 50, even though our network is working properly or not, that is totally depend upon ability to cope with node failure. The main issues in wireless sensor network is cluster formation. The cluster is consist of so many nodes. If 25% of nodes are failure, even though we are transferring data efficiently or not, that depend upon how the nodes are failure. That is the 6th one. Next, cross layer optimization. You go for network consist of so many layers. Every, as per ISO or OSI model, every network is consist of 7 layers. And the data transferring from top to bottom or bottom to top. When you go for source to destination, data is moving from top layer to bottom layer to top layer. That depends upon source or destination. In source, data is moving from top to bottom. Same thing in destination, data is moving from lower layer to upper layer. When data is moving from one layer to another layer, the main important layer is network layer. In network layer, the routing will decide. Earlier, we are going for source to destination. We have calculated these are the intermediate nodes from source to destination. When you go for any one node will failure, when any one node will failure, we can go for alternate path. That is multi-hop or multi-path. When you go for multi-path option, data is moving from layer to layer. Each layer is having certain routes, and it is the very, very important, that is cross layer optimization. Next is scalability of large scale of deployment. Scalability of large scale deployment. And already we know, whenever wireless sensor network is there, cluster formation is there. Whenever cluster formation is there, depend upon, first you will consider 50 nodes, then 100 nodes, depending upon next 150, 200. If our network is having 500 or 1000 nodes, when the nodes are more, the scalability or deployment of nodes is, formation of cluster is very difficult. This is the challenging issues when you go for deployment of nodes. Then node localization. Node localization is nothing but The data is, we are making, already we know in network, local area network is there, wide area network is there, and in between this one, we are having metropolitan area network. If you are connecting a group of nodes within the college or within the organization or within the company, that is called node localization. When node localization is there, security is there. But when you go for wide area network, the security is main issues. That is called encryption and decryption. We are giving security for data. When data is moving from source to destination, we have to go for encryption by giving private key, public key. And whenever public key is there, it is generated as source node. Same thing, it will go to a destination side. Using this private key, we can open the encryption. Before sending data, we are adding something to our message. It will reach to destination. Same thing in destination. We can remove the what key is added. There are two types of key, private key and public key. When our data is giving more security, we can go for private key. When we go for public, data can be accessed by everyone, but it should be accessed by only member of the cluster. At that time, we are giving public key. And last one is coverage and connectivity in heterogeneous. The main issues, connectivity problem. If 50 nodes are there, connection is very, very easy. When nodes are become more, connectivity is very, very difficult. If same type of nodes is there, that is called homogeneous network. When you go for heterogeneous network, when data is moving from one cluster into another cluster, but data is moving from one cluster into another cluster, that is how we are coverage. How we are coverage. That is coverage and connectivity in from one cluster to another cluster. These are the issues related to coverage and connectivity of heterogeneous. These are the 10 issues which are related to wireless sensor network. Till now, the work is performed on almost all first 6 is covered, and cross layer work is going on. And coverage and connectivities, these are the two challenging issues related to our wireless sensor network. And in the next slide, madam, that is related to how is our, hello, this is the architecture of wireless sensor network. And in this wireless sensor network, and this is cluster head. This cluster head is connected to all these 5 nodes. Each node is called source node. When data is sending from this node, it is called source node, and data can move from here to this node also. But this node to this node, we cannot send. We have to go for this node, sensor node connected to this, and this data is connected to this. And automatically source at the end, data is moving to base station. And here, every cluster head, it is receiving, it receives data from all the neighbor nodes, and then it sends it to base. Next slide. Madam, previous one slide is there. Check it, madam. One more. Okay, no problem, no problem. And quality of service. Whenever quality of service is there, it is related to quality of service. Best option, we consider our home network only. I want to make it as my home as a home automation using our wireless sensor network. When our home is there, we should have so many nodes, but here we cannot say nodes. Our fridge is there, TV is there, fan, cooler, AC, geyser, door, windows, and gate. These are, we can say it as a one node. I want to make it 100% home automation, and the gate should open automatically. using sensor. The gate should open automatically. The question will arise how the gate is open automatically. Then depend upon we are keeping one sensor in the gate. Depending upon my car or bike sound, depending upon my car or bike sound, the gate will open automatically. The question will arise how the gate will open, how can it will open depending upon my bike or my car. So this is the issue. And when my car or bike will come, the gate will open automatically. The bike or car is going inside the house, and I will off the bike or key, bike or car. The gate will open. The gate will close automatically. Same thing. I want to go outside. I want to go outside my compound wall. When my on fan or car or bike, automatically, when sound will start, the gate will open automatically. When I will take my bike or car outside the gate, it will move far away from gate. The sound is not listening. Automatically, the sensor will close the gate. This is the using wireless sensor. We can make it automatically gate open and close. You go for metro, how the door will open automatically and closing. Same thing we can adopt to our home. Then we'll go inside the house. According to my face recognition, nowadays, every house should have CC camera. In CC camera, whenever my face is recognition, or depending upon foot finger, we can put it in front of door, foot finger recognition. When I am standing on the foot finger, the door will open automatically, or depending upon camera. I will go inside the home, the door will close automatically. This is also related to our wireless sensor network. Suppose I came in the night, the gate light should automatically open. In front of the house, the light should on. Same thing, when I will go inside, automatically the light should on. Nowadays, we are using remote to control the fan. Depending upon condition of the room temperature, the fan speed may be increases or decreases depending upon temperature. Suppose the room temperature in between 15 to 20 degree, the fan is number 1. Same thing, 2, 3, 4, depending upon up to room temperature is 25 to 30 degree. When more temperature is there, the fan cannot work. We can go for cooler is there. Fan should off, cooler should on. Cooler can work up to 32 degree to 38 degree. Even the temperature is increases more than 38 degree. The AC should off. How can fan off, fan on? The speed of the fan increases, same thing, speed of the cooler also increases or decreases, same thing, AC should on, depending upon weather condition. This is also one type of the wireless sensor. Same thing, go for TV. So many people, they are watching the TV. When they are watching the TV is on, light is also on. Unfortunately, we are sleeping. When we are sleeping, automatically, when eyes are closing, automatically TV should off, light should off, zero bulb should on. These are related to wireless sensor network. Then same thing you go for our geyser. Suppose whole families went outside. They want to take bath. The geyser should on. It may take, nowadays it is coming within 2-3 minutes we can get it hot water. But 3 to 4 persons is there. It takes more time. When we are traveling near to our house, before 10 minutes we can on geyser, we can get it hot water. Same thing when you're going outside. Unfortunately, the current has gone, light and fan is on. We have to stop these two conditions, these two, by using IoT, Internet of Things. Using IoT, we can control all our automation. There is an improved version of our wireless sensor is nothing but Internet of Things. Using Internet of Things, we can cover, we can control everything. Nowadays, car is there. The car can move without driver. Without driver, you can go for hotel also. No servant. Even robot can serve for all customers. These are the days which are related to artificial intelligence. Nowadays, we are getting earlier computer science is there. After computer science, it has become information science. Now information science is changing. It has become A&M. Now you go for Japan, whole oil industry. One oil industry is there in Japan. Almost it is controlled by machines only, robot only. All these things are depend upon A&ML and same thing our wireless sensor network. Same thing you go for our fridge. In fridge we are keeping our vegetables. When things are become very less, suppose we are keeping 4 days vegetables. After using 2 to 3 days, we have forgotten to get the vegetables. And when vegetables are day by day less, when it has become empty or before going empty, we are getting one message alert to our mobile. You have to get vegetables when you are coming from office or when you are outside. You should get it alarm or like your SMS. And these are the technology related to fridge. Nowadays, everything controlled by us. Example, when you go for using of sink, when you go for sink, put your hand, automatically water will come and water will stop automatically. But depending upon condition of the, how much dirty of my hands, depending upon how much dirty my hands, depending upon dirty, the water should come. But till we are using only, when you flush, we are getting this much water. This is wasting of water. But instead of this one, suppose hand is clean, I want to wash. Before taking meals, I want to wash. At the time, we required only little bit water. Same thing when you go for after completion of meals, we required more water to wash the hand. All these are technologies related to our wireless sensor network. And already I told the issues which are related to wireless sensor network. The main aim is energy consumption. And one more is data security. These are the two issues. Cluster formation that depends upon how the nodes consist. If more nodes are there, congestion occurs more. When congestion occurs more, automatically the throughput is decreases. And related to this quality of services, already almost all I have covered. That is energy efficiency. Totally quality of services depend upon this energy efficiency. Next, data reliability, whether we can believe or not. When you go for communication, wireless communication, error correction, when you go for data reliability, error correction, whenever error correction is there, we can go for to recovery error, to recovery error. To recovery error, or we can transfer old data once again, that is called retransmission. Retransmission. Or we are selecting move data from source to destination. In between this one, any one node is failure. Then we can go for redundant path. We can search alternate port. Same thing, scalability, latency. These are the issues related to this. Scalability depends upon what? When number of nodes are increases, the network become complex. Whenever network become complex, we are getting which problem? Traffic load, longer routing path, and need for more complex coordination between node can degrade quality of service. The quality of service totally depend upon what? Traffic load, longer routing. Same thing, latency. That is, it is called prioritizing traffic. Optimization routing protocol are ongoing of area of research. These are the some issues related to quality of service. Next slide. It is heterogeneous network, same thing, dynamic network conditions. If there is a fixed network, then no problem. Moving of nodes from one cluster to another cluster. When your wireless sensor network is there, dynamic network condition is we can move one cluster to another cluster. When we are moving from one cluster to another cluster, link quality, node availability is very important. And the next one is application specific quality requirement. Different application have varying quality requirement, real-time monitoring or predict data collection. Real-time means ongoing. Whenever one node is moving from this cluster to another cluster, and it will affect on real-time monitoring. Periodical data collection depends upon our node condition. When a node is getting some information, then that information moving from node to cluster 8, from cluster 8 to base station. Next slide. Next slide, madam. Security issues, already we have discussed. Resource constraint, physical node compromise, scalability of security, key management. Whenever key management is main rule in our security management, that is related to encryption and authentication. Authentication means this node is belongs to this cluster. And when we are doing encryption, we are providing public key, private key. That is possible by using cryptographic keys. Using cryptography, we can add when we are before sending message. After receiving the message, we are extracting that key. Afterwards, data can be sent to our destination. Next, madam. Hello. Secure routing. Routing is main in our networking. When data is moving from one node to another node, or one cluster to another cluster, or from cluster 8 to base station, various attacker will come to hide our data, to give security for our data. We are going for security issues. And when data is received from so many nodes, all this data can be integrated. We can make it data integrity, end-to-end data integrity, and authentication, whether we have received data correctly or not. Next, that is related to DOS. DOS attacks due to their limited resource. In our wireless sensor network, each node receiving limited resource. Whenever limited resource is there, attacker will attack our data to give the quality of service. We can give it by using security method. Next one, madam. Next slide. Energy efficiency. That is the main thing of our energy efficiency that depend upon our sensor network. Sensor network having limited energy. Whenever limited energy is there, when each node, sensor node want to send data, the sensor should off. After sending data, sensor should off. Using on-off function, the energy level will be reduced. When energy level will be issued, uses less, and the performance of the network is increases. Next, madam. Next. Next, madam. Network throughput. Network throughput depends upon bandwidth limitation, energy efficiency, and already we have discussed about energy. How is the energy is more important than our sensor network? Same thing when we are transferring data from source to destination, that depend upon bandwidth. Depending upon bandwidth, the limitation affects data rate and throughput. When these two are affected, the performance of the network is reduces. The throughput of the network is also reduces. Scalability issues, network density. As the number of nodes increases, congestion will occur. When congestion will occur, there is a collision between one packet to another packet. When collision will occur, possibility of data lossing. We can go for to recovery data. We can go once again for retransmission of data. When we will go for retransmission of data, same we required energy. That is an energy problem. Next, routing overhead. Routing overhead maintains routing table. The node is transferring data from one node to another node. We are maintaining table. Using this table, we can use shortest path. When your shortest path is there, the routing will, the data is moving from source to destination with less time. Data aggregation, fusion, that is depend upon redundant of data. Redundant means multiple sensor might collect similar data. There are so many nodes are present. Multiple sensor, each sensor collecting same data. Node A is collecting same data. Node B is also collecting same data, and automatically replication of data will arises. When replication is there, redundancy will occur. When redundancy will occur, it will affect on network. The main aim is to reduce the redundant transmission and improve the throughput. Next, fusion technique. Combining data from multiple sensors. We are getting information from so many sensors. We can get meaningful information. Meaningful information can be complex and might impact throughput. If we are not doing, it will reduce us the efficiency. Next, madam. Next, madam. Next. Node failure. Early, madam. Early. Next, madam. Next. It's over, madam. This is
Hello, any questions from audience?
issues related to our topic. If any questions,
Hello?
hello,
Yeah.
sir.
Just, I think there are no questions. Thank you very much, Dr. Nagraj Patil.
Yes, sir. Thank you, sir. Thank you.
Yeah. And so we have next session by by Dr. Lohit JJ. Lohit, hello. Yeah.
Yes, sir.
Welcome, Lohit.
Yeah, thank you, sir.
On behalf of all the participants, welcome you to this session.
Thank you.
1 second.
Thank you, sir.
Yeah, we have with us Dr. Lohit JJ, who is professor and head of Department of AI and ML, Nagarjuna College of Engineering and Technology, Bangalore, and is delivering a talk on introduction to cryptocurrency and technology behind it. Over to you, Lohit.
Thank you, sir.
Thank you very much.
Yeah, very good evening. Sir, can you know what is the time that is allotted to me now? Because all it's all 5:50.
30 minutes, Lohit.
Okay, thank you.
Yeah. Now we can just keep up to
Yes,
6:15.
Sure. Yeah.
Now it's 5:45, 5:47.
Sure.
So you can take up to 6:20.
Yeah.
Not an
Thank
issue.
you.
Yeah, please carry on. Thank you.
Yeah. Good evening.
You can share the screen. You have screen, right?
Yes.
Yeah.
So I hope is my screen visible? Is my screen visible? Can anyone interact here?
Yes, sir. Visible, sir.
Yeah. Okay. So I welcome you all for the session on introduction to cryptocurrency and the technology behind this. So the outcome of this today's session will be you'll be able to understand the concept of blockchain technology, okay, and concept of cryptocurrency. What is the technology behind the cryptocurrency and how exactly Bitcoin and blockchain works. So basically here, so let us understand. Initially, we have a Microsoft Word. Suppose now, if you want to draft any data, then we used to type the data in the Microsoft Word. Then we'll share the data to other person, right? But there are some drawbacks. So everyone has to type the data in the Word, and it needs to be shared. Okay. To overcome this drawback, we were using Google document. That is sharing of information. I think everyone have used the Google document, right? Wherein you create the Google document that can be shared with anyone, and parallelly the information can be shared. So this is what the traditional way of sharing documents. But still, there are some drawbacks here. So what is the drawback here is the environment that we are using is still centralized. We know that what are the problems with reference to centralized system. So centralized system harm the environment, right? That means single point, okay, and synchronization problem. All these problems arise with reference to a centralized system. Okay, and if it doesn't have a sufficient bandwidth to load Google document, you'll not be able to edit. And if the entire server crashes wherein your data is stored, then you'll be losing that particular data. Okay, next you have centralized versus decentralized versus distributed system. These are the terminologies that we come across in blockchain technology. Okay, so what do you mean by centralized system? Wherein you have one particular server, and all the server will be shared to all the nodes. Okay, decentralized means so the server will be centralized everywhere, multiple points of coordination. Okay, and distributed means every node acting like a server. every node acting like a server. That means, so it is an independent device in which no centralized point of service. So that is what the concept of distributed. So why this centralized or decentralized or distributed concept is required here is because blockchain technology, which follows that decentralized and distributed. So a possibly ideal solution for all the problems that we are come across using the Google document, a centralized system is everyone edits on the local copy of the document and the internet takes care of ensuring consistency. That means you have a copy of the document wherein anyone can edit that and make ensuring the consistency will be taken care by the internet. So this solution, that means, is termed as blockchain, the internet database to support decentralization. So as you can see here is a blockchain in simple, a decentralized database with strong consistency support, decentralized. That means every node has a same copy of the data. So a node which are part of the blockchain technology has this copy. That means every node has the same copy of the data. So now let us have the simple look of the blockchain. Now here, as you can see here, the circle is nothing but the node. So every node maintains a local copy of the global data sheet. Right? The system ensures consistency among the local copies. The local copies of every node is identical. As I told you that every circle that is specified here in the diagram is having the identical data, and the local copies are always updated based on the global information. What is global information? Now, when the data is shared by any of the node, that is updated at all the local copy of the nodes. That indicates that every node in the blockchain will have the same copy. So we call this as public ledger. I think everyone are aware of the term ledger, right? So which we have come across in transactions. Ledger is nothing but all the financial transactions that are stored in the a document. Okay, so a database of historical information available to everyone. Why it is called historical information? The thing is, all the transactions are stored in that ledger. That means, so from whom to whom the transaction has been done, how much money is transferred, all the information will be available to everyone. The historical information may be utilized for future computation. For example, now I have some 10 lakhs rupees. I have sent 1 lakh to one of my friend. Okay, when my friend is transferring that amount to other person, now that historical information will be useful so that anyone can accept that as a transaction. Without having money, if you try to send a transaction, that becomes invalid. For example, here, the historical information are the banking transactions, right? All the banking transactions are termed as historical information. The old transactions are used to validate the new transactions. So let us see an example here. So I hope that everyone able to see this diagram. So example of a public ledger. Now assume this is an public ledger wherein, so public ledger of Alice is showing Alice is having 100 rupees. Public ledger of Eve is showing Alice is having 100. Public ledger of Bob is showing Alice is having 100, and public ledger of Jen is also showing Alice is having 100. This is what the public ledger, wherein everyone will have the same copy. Now let us see some transactions here. Now Alice has sent some 50 rupees to Bob. So this is done as this complete as one transaction. Now this has to be validated. How do you validate this? Based on the previous transaction. Now everyone knows that Alice is having 100 rupees, right? So from that 100 rupees, Alice has sent 50 rupees to Bob. So anyone can validate this. Yes, this is accepted. So once the transaction is accepted, that will be updated in the ledger. So as you can observe here, the same transaction Alice sent to Bob 50 is updated in everyone's ledger. Now, Bob has sent 30 rupees to Eve. Is it a valid transaction? Yes, of course, because recently Bob has received 50 from Alice. So Bob is able to send 30 rupees to Eve. This is also updated. As you can see that every public ledger is updated with the transaction. Bob is having, Bob sent Eve to Eve 30 rupees. Now, see the another transaction. Alex is sending 80. Is this a valid transaction? Anyone? Can anyone interact here? Is this a valid transaction? Any answers? Fine. This is not a valid transaction because initially Alex was having 100. Then from that, Alex has sent 50 to Bob. So Alex was having only 50, right? But still, Alex is trying to send 80 as a transaction, which is invalid. So, which are part of blockchain network are able to validate the transaction. Either validate or invalidate based on the previous transactions that are available in the public ledger. Right. So this transaction is invalidated. So in simple now, right? So well, let us understand that what is a blockchain and working of a public ledger. So however, we need to ensure a number of different aspects. There are protocols for commitment. What's the protocol? So in simple, we have understood that protocol is a set of rules. So there are some protocols that are required for commitment of this. So that every valid transaction from the clients are committed and included in the blockchain within a finite time. So in the previous cases, we have seen all the transactions, right? So all those transactions, when it is broadcasted, every transaction is broadcasted and it reaches every node. Okay, when a node receives the transaction, right, anyone can validate or invalidate the transaction. Once it is validated, then this transaction has to be included in the blockchain within a finite time. So for all these things, you have a protocol which takes care of all these things. Consensus. What do you mean by consensus? Consensus is a mechanism wherein when you decide on something that should be accepted by everyone. So when ally sending 80 to Eve is invalidated, so that is accepted by everyone. When anyone tries to validate that, any other person tries to validate, which is an invalid transaction, that cannot be accepted. So consensus is a mechanism in which, right? So when you take a decision, everyone should accept in such a way that you have to take a decision. This is what the consensus mechanism. Security. The data needs to be tamper-proof. This is what the major advantage of blockchain technology. What do you mean by tamper-proof? Once the data is stored in the blockchain, it is immutable. What do you mean by that? Once the data is stored in blockchain, you cannot modify the data, right? So this is very, very important advantage of blockchain technology, right? Note the client may act maliciously or can be compromised, but the data remains immutable. Privacy and authenticity. The data belongs to various clients. Privacy and authenticity needs to be ensured. So once the data is nothing but transactions. When the transactions are stored, and one thing here is every node which are part of blockchain are uniquely identified by the address, the name. So which in this address is uniquely identified by public key and private key. So I think some concept related to cryptography is required here, right? All the nodes, like how all the devices which are connected to internet are uniquely identified by IP address. In the same way, the nodes which are part of blockchain technology are uniquely identified by the address. And this is also one of the drawback with reference to privacy and authenticity, right? So this is where the cryptocurrency like Bitcoin is not legal in India, right? We'll come across that. Okay. So now let us look at a formal definition of a blockchain. A blockchain is an open distributed ledger that can record transaction between two parties efficiently and in a verifiable and permanent way. What do you mean by open? Open means accessible to all. Anyone can be part of the blockchain technology or network. distributed ledger, no single party control, no single party control. Every node is acting like a server. Okay, and efficient, fast and scalable. Internet takes care of that efficiency, and so more number of nodes can be added to the blockchain network. Verifiable, as I told you that, right? Based on the previous transaction, any node can verify that transaction, either validate that or invalidate that, and permanent. So once the transactions are validated, once the transactions are stored in the blockchain, it is permanent. So this is what the formal definition of a blockchain. So in simple, so blockchain is nothing but a distributed ledger which can store data permanently, right? So now we can say that what are the applications of a blockchain? Blockchain is used everywhere. Name the what do you call area, right? I can tell you that whether the blockchain fits into that particular area or not, because this is used to store the data in a permanent way, wherein once the data is stored, you cannot modify that data. This is what the biggest advantage of blockchain technology. Okay, now let us see the prerequisites of blockchain technology, right? What makes that blockchain technology to be immutable? As I told you that once the data is stored in the blockchain, it is immutable, right? How? What makes the technology to be immutable? So the first thing here is the usage of the concept called as hash function. I think in cryptography, we come across the hash function. Hash function is nothing but a one-way function, right? For a given data, you can find out the hash value, right? Then for the data, you get hash value. By having that hash value, you cannot get back the data. It is not reversible. Please understand that hash functions are one-way function. Okay, so let us see some example here. Okay, see here. So cryptographic hash functions here. So example, you have a message register 5, secure hash algorithm 256, 512, like this. We have different forms of hash functions. Okay, now you can see the input here, Fox. This is the input. When this input is fed to a cryptographic hash function, it creates a hash value, which we call it as a digest. Right. Now see the second example. The red fox jumps over the blue dog. This was the input. When this input is fed to the cryptographic hash function, it creates a digest. See the third example. The difference between the second input and the third input is a small character. In place of OVER, we are using OUER. Right. But see the output of the hash, there's a drastic change. When there's a small change in the input and it leads to a drastic change in the output, this we call as an avalanche effect, which you all come across in cryptography, and I think in what you call DSA algorithm. Right. So this is called as the avalanche effect. This effect is also holds good in hash functions. When there is a small change in the input, right? So it leads to a drastic change in the output with reference to hash functions. Okay. Next, timestamp document. What is this timestamp? When do you require this timestamp? Whenever a document is created, at that instance, we add the timestamp for the document, for the digital document, to indicate that which time exactly the document is created. Okay, so here you have a sequence of timestamps, TS1, timestamp 1, timestamp 2, timestamp 3, like this, right? So here we have a hash of, right, 0, C1, timestamp 1, hash 0. Then you find the hash of everything, then it becomes H1, like this, H2, H3, H4, to indicate that when exactly the document is created. Okay, now, so here we have the concept of Merkle trees. Everyone have come across binary tree or other stuff. Then what is this Merkle trees? Okay, Merkle trees is a very important which are used in blockchain technology to store the data and to find the hash of the data. For example, as is that now we have 4 data 1, data 2, data 3, data 4. Okay, now you find the hash of data 1. When you find the hash of data 1, it creates a unique value. That is nothing but h of 0, 0. Similarly, you have a data 2, hash of D2 will be H01. Similarly, you have data 3, hash of D3 will be H10. Similarly, you have data 4, hash of D4 will be H11. You have 4 data, right? Now, club the 2 datas hash together, H00 and H01, right? Add that hash of H00 plus hash of 01 will become H0. Similarly, hash of 10 plus hash of 11 will become H1. Then again club H0 and H1, right? Hash of H0 plus hash of H1, that becomes root hash. So every blockchain node will have a root hash, which is in turn hash of all the data. So this is, we call it as hash tree, right? This hash tree is constructed with the help of a Merkle tree concept, which was developed in 1979 by Ralph Merkle. Okay, this is what the Merkle tree mechanism that is used in construction of blockchain node to store all the data hash values. Right, let's not. Now, this is what the blockchain. Now, how this blockchain is related to Bitcoin? So everyone aware of that? What is a Bitcoin? Bitcoin is a cryptocurrency, digital currency. Now we have our rupees as a currency, Indian market. Right, assume that now we want to go to US now. Right, we know that we cannot use the Indian currency rupees. Right, so we need to convert that, exchange that Indian currency to US currency, dollars. Next time when you go to Europe, Indian currency is not accepted. You need to convert that to euros. So every nation has its own currency. So you need a digital currency which will be accepted worldwide. So for that, you have a cryptocurrency, digital currency, which is the first cryptocurrency is called as Bitcoin. Right? Bitcoin is a completely decentralized, peer-to-peer, permissionless cryptocurrency put forth in 2009. The first paper published by anonymous author Satoshi Nakamoto, who was responsible for developing this Bitcoin, is an anonymous. Nobody knows that who is the author of that publication. He is the person who have developed this cryptocurrency, completely decentralized and peer-to-peer. Every transaction takes place from one node to another, peer-to-peer, and a peer-to-peer permissionless. That means anyone can be part of that. Okay, so let us not go. So see here, the technology behind Bitcoin is blockchain. Why that Bitcoin is powerful is it uses blockchain technology. So as we already discussed that, what exactly is that blockchain technology? So here we have a Bitcoin, which is a cryptocurrency, Indian cryptocurrency. So this Bitcoin uses blockchain technology. Prior to 2008 also, blockchain technology was available, but it was not pretty famous. After this Bitcoin publication, this paper, right, blockchain has evolved like anything. So blockchain is a very powerful technology. Later on also, right, in 2013, right, so Ethereum blockchain has evolved, which used the combination of powerful of blockchain technology, then using of smart contracts, which has evolved in 1995. Ethereum blockchain, right? So all the transactions, and Bitcoin is limited to financial transactions only, right? As it is a cryptocurrency, so you can send a Bitcoin from one person to another person. So as you all know that blockchain, as Bitcoin is a blockchain, every transaction is updated in the blockchain. So there is no scope for cheating. At any point of time, say receiver cannot deny that he has not received, or sender cannot deny that he has not sent. Contain multiple transactions also. It's not that one transaction is stored in one block, right? A block on an average can consist of 500 transactions. Every transaction is broadcasted. So let us see now Bitcoin transaction life cycle. how exactly Bitcoin transaction starts and how it is stored in the blockchain. Now, it's simple like assume that now we have a phone pay, right? So for to perform any transaction using phone pay UPI ID, right? Similarly, right? So suppose now to do any kind of Bitcoin transaction, you should have a Bitcoin wallet. And Bitcoin wallet is uniquely identified, like how your UPI ID is there, right? Similarly, Bitcoin wallet is uniquely identified by address. So to send any kind of transaction, assume that now between Alice and Bob, Alice opens a Bitcoin wallet, provides the address of Bob to whom she need to send the transaction or Bitcoin and the amount to transfer and sends. As simple as this phone pay, right? You need to send the money to your friend's phone pay account, right? So you open that phone pay app, specify that to which UPI ID you need to send, then what is the amount, then you click on send. This is also simple, but only thing is, like phone pay UPI ID, you should have a Bitcoin wallet. This wallet will be uniquely identified. But only thing here is, as you open a Bitcoin wallet, nobody knows that who is using that wallet. This is what anonymous. Bitcoin transactions are banned. Usage of Bitcoin is banned in India because of this anonymity. I think everyone are aware of that ransomware attack which has happened some 4 to 5 years back, right? So ransomware attack happened, and these people, they have collected the sum through this cryptocurrency only. All kind of illegal transactions, all kind of underworld transactions through this Bitcoin only, because no one can identify who is sending the amount. Only they can identify what is the sender address, what is the receiver address. Now, if I give that, right, if I'll ask them, I'll insert some kind of virus to some devices, right, and I'll ask them if you want me to remove that virus, you send the currency to my particular wallet address. Only when they send this, I can remove that particular virus. This is where anonymity exists, right? So based on this only, right, Indian government has banned Bitcoin, usage of Bitcoin in India. But elsewhere in the world, this transaction is accepted. So now the wallet, once you try to send the transaction, the wallet constructs the transaction, sign using Alice private key. You need to authenticate the transaction, right? So you have to authenticate that using the sender's private key and broadcast it to the network. So at any point of time, right? So we will validate that based on the Alice public address that the transaction is sent by Alice only. The network node validates the transaction based on the existing blockchain and propagate the transaction to the miners. Now, I'll come to know that whether Alice is having the sufficient amount or not based on the previous transactions. So once that is done, then I'll propagate the transaction to the miners. Who are miners? What is the mining? For example, we all seen gold mining, right? It is nothing but a digging the gold from the earth. Similarly, right, here mining is nothing but all the transactions which are validated, they're all stored in a block that needs to be mined, right? So what is a mine? Mine is nothing but, now it is simple, right? Now all the transactions stored in a block. Now in the entire block, you have a fill in the blank, wherein, right, it is nothing. We calculated the hash of that entire block, and that is filled. So now this block is broadcasted to miners. There are n number of miners. There are software companies who are working like a mining companies. People are minting money through this mining. Each common man also has an opportunity to mine a block. Right. Now, when the miner receives this block, they want to find out what is a random number so that their generated random number hash will be equal to the hash of that existing blockchain that is sent. When both are equal, then only automatically the block will be accepted and stored in the blockchain. To do this, right, you require huge devices. And people are minting money through this mining. For every couple of seconds, mining happens in real time. You can see Ethereum blockchain, Bitcoin, different blockchain networks. In every network, mining happens. Even I can also do mining. Even you can also do the mining, but you require a suitable configured device to do that. It is nothing but you need to find out a random number. So when you find out the random number, for every random number that you have generated, it creates a hash value. So this generated hash value, if it is equal to the hash value which you have received, that indicates that you have mined. And the miner who successfully mines the block will be rewarded. That is where you see money, right? So once the mining is over and the hash is obtained, the block is included in the existing blockchain. The updated blockchain is propagated in the network. Now, the Bob, see, this is what the transaction which are sent by allies, it has undergone all these stages. Bob opens his Bitcoin wallet and refreshes, the blockchain gets updated, that you will receive that the alliance has sent some kind of Bitcoins to his wallet. This is what the Bitcoin transaction life cycle. Is it clear? Participants? Any doubts here? So I'll open the session for question answers.
Hello.
Yeah.
Any questions from audience? I think they don't have any questions, Dr. Lohit. Thank you very much for your very informative session.
Yeah. Thank you,
Very
sir.
nice to meet you after a long time.
Same here, sir.
Yeah. I think you've taken a new role. I wish you all the best.
Thank you, sir. Thank you.
And on behalf of all the participants, I thank you sincerely for spending your valuable time and sharing the insights on this new technology. Thank you very much, Lohit.
Thank you, sir. Thank you.
Thank
It's a
you.
pleasure. Yeah. Thank you, everyone. Yes, if you have any kind of doubts, you can contact me through my mail ID. Thank you.
Yeah. Just you shared your mail ID, right?
Yes, sir. I have shared that lohitjj@gmail.com.
Yeah.
I'll post in the group also, a chat box.
Yeah. So next we have Dr. Siddhana Gowda. Siddhana Gowda, are you there? Hello? Hello, Siddhana Gowda?
I'm here, sir.
Yeah. Okay. So we have third session by Siddhana Gowda. Dr. Siddhana Gowda. Is in Department of Civil Engineering from Government Engineering College, Raichur. He is working on India's environmental pollution and its impact and challenges for sustainability of civilization. On behalf of all the participants, I welcome you, Dr. Siddhana Gowda. Over to you.
Good evening, all. I'm privileged to be part of this program. I thank Department of Technical Education for providing me this opportunity to share few of ideas about the environmental pollution, India's environmental pollution, its impact and challenges for the sustainability of the civilization. In fact, India is having abundant natural resources in terms of rich quality of soil, hundreds of rivers and tributaries, lush green forests, plenty of mineral deposits beneath the earth crust, vast stretch of coastal length of Indian Ocean, ranges of mountains, etc. So a nation of vast resources and having a very large number of dependent population on these resources. Hence, challenges are that in order to have or to transform from the developing nations to the developed nation, we have to have the wheel of development continually roll using available resources for the development. A development paradigm that has exacerbated these challenges. The pollution poses one of the greatest threats to the sustainability of modern civilization. Hence, my topic is everybody's topic. So every citizen has to think about that, and the role of every citizen has to come into picture. It comes in various forms like air pollution, water pollution, soil pollution, and noise pollution, and it is primarily caused by the anthropogenic activities, transportation, waste disposal, agricultural practices, and energy production. As the global population grows, The economies expand, the pollution has intensified, raising serious concern about its impact on both human health and environment. Sir, understanding this, the impact of these pollution and finding solution is business as usual. So the air pollution, water pollution, soil pollution, and noise pollution are to be of great concern for the humanity as well as for the entire globe. So air pollution is having criteria air pollutants in the form of ozone, particulate matters, carbon monoxide, lead, sulfur dioxides, and oxides of nitrogen. So ozone, at the elevated temperature, nascent oxygen combines with natural oxygen and forms the ozone, which will become really threat when it is in excess concentration. So particulate matters which are of less than 2.5 microns are respirable, and these respirable particulate matters are of great concern for the lungs. So they pose a great threat to the lung disease. The carbon monoxide, the another the emission, which is mainly from the vehicular emission, and for the unburned fossil fuel, it poses a great threat. And carbon monoxide, which is actually having affinity towards the hemoglobin, and it combines with the hemoglobin of the blood, and it forms the carbon monoxide hemoglobin block, and it blocks the oxygen carrying capacity of the blood, and it is fatal for the human health. So lead, which is there in the fossil fuel, is also a threat, which is in excess concentration. It inhibits in the vital organs, and it will become great threat for the human health. So these oxides of sulfur and nitrogens are of a great concern. So when we burn the fossil fuels, so these actually emissions are getting into the atmosphere and forming in suspension. Whenever we receive the first shower, it will become acidic, and the acid rains are going to be formed. And sources, as I said, the vehicular emission, industrial activities, the construction dust, crop stubble burning, and coal-based and fossil fuel-based power plants will emit all these the pollutants. And these pollutants which are in suspension, and whenever you have a meteorological inversion, so they stop the warm air, stop the cool air, and it forms the shield and prevents the pollutant from rising and scattering into the atmosphere. So when this condition happens, there is a formation of smog. So as we have seen in almost all the metropolitan cities, so this is hindering the visibility, and also so smog, which is having a large number of pollutants, will become great threat for the human health. So this smog also initiates the photo activated reaction, chain reactions, and that leads to the carcinogenic the gas formation or the emission, pollutant formation, and that leads to the cancer. So to abate this air pollution, some of the acts which have been established, and these established acts are in action, and they will going to provide greater enforcement regulations, which will actually reduce the air pollutant emissions, and placed an increased emphasis on more cost-effective approaches to reduce the air pollution. Whoever is responsible for these the air pollutants, so these stringent regulatory actions will abate this, or this will control this air pollution or air pollutants which are going to be unabatedly emanating into the atmosphere. By reducing air pollution, the Clean Air Act has led a significant improvements in human health and environment in the US. In the same line with Indian context, some of the stringent regulations which are enforced are leading some drastic improvement in the quality of the air. Since 1970, the 6 commonly found air pollutants have been decreased drastically to the level of 50% wherever these actually the stringent actions are there. Next comes the water pollution. As you know, the water is not an inexhaustible resource, even though we are we are thinking about the water budget where uh, uh, we are constantly getting from the rain, but it is not uh, uniform throughout the globe. Or in the Indian context, the rain is not uniform. So therefore, the water mainly what we are receiving from the rain is not going to be stored or preserved or conserved everywhere on the surface of the earth. So therefore, this leads to the surface water source, which are actually having a larger uh, the water bodies, which are actually useful for the water consumption. They are getting contaminated by the waste disposal and disposal of the pesticide, which are leaching from the agricultural lands, and inadequate or ill-planned treatment infrastructures. They are leaching into these water bodies, and they are getting contaminated. Cities which water draw from the sources are also getting away and away, and that leads to the conflicts. The groundwater, mainly the countryside, we are depending on these groundwater as the source. So there is a huge pressure on the development of the groundwater, and that leads to the depleting or decreasing the groundwater level, and also the depleting aquifers. And the climate change is also actually contributing for this impaired, erratic, ununiform distribution of the rains. And these long spells of the droughts and devastating floods are also the contributing for the scarcity of the water.
Madam Vani?
Yes, sir.
Hello?
Yes, sir.
Madam, can I just, I think there may be some problem with the other speaker.
Okay.
Can I continue now? Can I start?
Yes, sir. Yes, sir. Yes, sir. I'll start.
Yeah, I can. There is some technical issue with Dr. Sudhana Gowda.
Okay.
I request Dr. Ms. Vani KS, Assistant Professor, Department of Computer Science and Engineering, Indian Institute of Technology, Bangalore, to deliver a talk on machine learning and IoT for healthcare. On behalf of all the participants, I welcome you, madam. Madam, you can continue. You can start sharing your slide and you can continue.
Yes, sir. I'll start, sir. Sir, I hope it's visible, sir. Slides are visible. Screen is visible.
Yes, ma'am, it's visible.
Okay.
Slideshow.
Thank you.
Slideshow.
Yes, ma'am. Thank you. Thank you.
Yes, yeah.
Good evening, all. Thanks, Basarat sir, for this opportunity given for me to talk for the AROHAN 2024 series, lecture 14 series. I welcome you all for this lecture 14. I also thank the other resource persons of today for such wonderful sessions. So today I thought I'll talk about machine learning and IoT in healthcare. So regarding this machine learning and IoT, how they have transformed this healthcare, how they have transformed this entire health business, let me give some introduction to machine learning and IoT. So from the past 10-15 years, I hope everybody knows that machine learning has become a part and parcel of everyday life with us. So coming to the definition of that, I think it's a branch of computer science and engineering that focuses on how to use the data. It is not about collecting the data. It is all about how to use the data and the algorithms which are already there, which are already written, trained, so that these algorithms or along with the data, they imitate us so that we learn how, so that algorithms learn how actually the humans think, how actually the humans work, how actually the humans think and act. So that is all about machine learning. And IoT, again, it is nothing but a network of devices. The devices can be of different type. It can be a sensor, it can be a mobile, it can be a printer, it can be any household device, wearable devices, where they all are connected together, where they also share the data, send the data, retrieve the data through the use of any cloud computing techniques. So like this, machine learning is one entire different topic, and IoT is a different topic or an area it is. Combined together, these two combined together has it's doing a lot of magic nowadays. And especially I thought I'll tell about these two technologies when they merge, how it is transforming this healthcare businesses, how it is helping the healthcare sector. So like this, I thought I'll tell you about some basics of machine learning and IoT, how they help us for the healthcare sector it is. So usually, as I told, the IoT, it taking the data, it collects the data. Maybe it is temperature of the room, temperature of a human, or maybe some human body readings, some patient readings, some room what environment measures it is. Where whatever it is, they collect the data. IoT collect the data with the help of sensors. So like this massive amount of data which is there, so to read that, understand that, predict that, it is very difficult for a naive user or maybe a normal usage it is. So this ML can help us to read, analyze that massive volumes of data, and it can replace this manual processes, manual predictions, manual analysis which are there. So that we'll go ahead with the automated systems, and it will help us a lot. So I can also tell that this integration of ML and IoT has transformed a lot. It is like how business operate, how these products are designed and manufactured. Everything has been how the services are delivered and how to improve the customer experiences. Everything is changing nowadays because of these two fields integration. Yeah, just as an overview of this entire thing, whatever I told it till now, this is just an architecture of this ML and IoT integration, where the center one talks about the smart healthcare system, which can be an app within a mobile devices or a tab or something it is, where this app, it collects the data from all the sensors which are there on the body, wearable devices, or maybe in the home or in the room. So these data are sent to the data center where the data analysis has been performed by the by the experts, or maybe the automated data analysis is done. Also, parallelly, the data is analyzed by the doctors, nurses, everything. For whoever is having this device, they have been measured. And also this data has been sent to the IoT. That is nothing, either to the caretakers, or maybe when they are traveling, or maybe it is somewhere else it is also been sent. The patient's data is also monitored. So like this, with the help of this IoT, they have analyzed, they are checking out the health status, they are monitoring the patient data continuously, they are monitoring their caretakers, elderly people at home. Everything is being done of all these integrations. So coming to the advantages or benefits of all this integration, it is, as I told already, it can help for the automated quick processing, timely interventions. It is because huge amount of data gets collected every second, every minute. It is to analyze this massive amount of data, humans are, we may not be able to up to the mark. So that efficiency of the predictions of all those massive amount of data is good. Accuracy, again, it is accuracy improves because ML is nothing but it continuously improves. It learns from the data, it improves. It is so once it improves, it improves on the accuracy. It is so there are less chances of false RRM, and better diagnostic capabilities will be there, and proactive interventions. So it is nothing but it is not about after something happening we take the action. It is ML and IoT can also help us for proactive care. So that is, it can analyze the patterns, recognize the anomalies in the data, which is so that it can alarm, it can provide the early interventions in the patient's data or the caretaker's data. Okay. Some of the other applications of ML and IoT in healthcare can be maybe in office situations where the employees' data, employees' health records, employee health data, because of the wearable devices, or maybe in the office sensors, it's been continuously monitored. Their BPs, their sugar levels, their glucose levels, everything are being monitored. So the employees are always monitored about their health status. So we also can detect some tissues, some what I can tell, cancer detections, early cancer detections can be done, or maybe using the like patients at the remote places where they don't have any caretakers, they have some elderly people at home. So that also can be monitored. And nowadays the apps are there for what I can tell, prescriptions, doctor prescriptions can be taken in the app only. So that is usually in English, but because of this NLP and ML other techniques, even the patients can even tell about their diseases, they tell about their symptoms in their native language. So that also can be done. And the skin lesions, skin cancer detections can also be done. So these are some of the other applications of ML and IoT which can help us for the healthcare sector. Yeah, some of the sensors, what I told is about the heartbeat sensor, ECG sensor, humidity sensor, the temperature sensors, oximeter sensor, BP sensing. So many other which can help us to detect the brain hemorrhage, or maybe the hypoglycemia, high BPs, high sugar levels, the disadvantages of that. These are some of the other applications of ML and IoT in healthcare. Yeah. So today, after I told you about all the introduction of ML, IoT, and the integration of these two fields in the healthcare sector, I thought I'll talk about one such application, one such scenario where this integration has brought a lot of changes in the health sector. So one such detection is the cough sound detection and the diagnosis. So what is that is the cough sounds which are related to some of the diseases, like maybe it is pneumonia, tuberculosis, COVID-19, or maybe any type of respiratory diseases, respiratory diseases where the cough sounds are the major prediction parameter it is. So how this cough sound detection and diagnosis will help us. So the sound and the type of cough are the two useful features which will help us to analyze what is the type of the disease, what is the disease actually it is, whether it is a bronchitis, whether it is a tuberculosis, whether it is some pneumonia patient it is. So it will help us to predict very accurately. So one such, what I can tell, the statistics, one such data which has been taken from 2011, I would like to tell, where pneumonia was, it has brought it 1.3 million children under 5 years old, it has killed it. So nearly 75% of these deaths were there from Africa and Southeast Asia, where it was affecting the underprivileged and the poor population. But again, the study had shown that out of all the deaths which had occurred, 1.3 million deaths which has occurred, 65% of the death could have been prevented with the right interventions, with the right diagnosis and the right measures taken. So this is one such data which I got it, so that which will help us to understand how important the cough sound detection will help us. So I would like to also tell about the human sounds. It is different in normal breathing, speaking, coughing, wheezing, snoring. Every of such actions, the human sounds it differs. So, but detecting this cough sounds, because a patient, a child, especially here, I am talking about the child patient's analysis. When they go with the cough symptoms, usually the physicians fail sometime depending on, maybe the other blood test will be done, maybe the other scannings will be done, different things will be done. But depending on the cough sound itself, how can they help us is about all this example or the sample study, which I'm talking about. Yeah, one such methodology, what I would like to tell it is about this. As I told, many other measures are there, what the physicians, doctors use to detect whether it is which type of respiratory disease. But one methodology, what I'm talking about, is purely based on the cough sound analysis. So coming to the overall methodology of the sample, what I'm talking about, what about the study, what I'm talking about, you usually need a data set here. A data sets can be available. I think a lot of sources are there where we can get the data, where the cough recordings of different patients, different children have been taken. Where Kaggle is the best source where we can take the data set it is. It has been denoised. The first step here, it is in the methodology, is the denoising. Denoising is nothing but removing the unwanted noise in those recordings which have been taken from the patients. Maybe it is the background sound, maybe it is some speech which is there, so that we concentrate only on the particular that sound sample. So denoising should be done first, remove all the unwanted noise, unwanted data, everything. Cough segmentation has to be done. Cough segmentation is nothing but we detect where is the start of the cough sound and where is the end of that cough sound. So maybe before that some speech is there, after some speech is there. So we have to properly segment that data, properly segment that cough sample which we needed. So segmentation has to be done. And then we take the features. Features are nothing but from that cough sound, I extract what is important for the predictions. Maybe it is the pitch of the signal, maybe it is the what I can tell tone, or maybe of something else, some other features which are there, which has to be extracted for the machine learning purposes. So then the algorithm training will be done. Machine learning comes into picture, where it can be, here the sample tells about MLP training, multi-layer perceptron training, but the trainings can also be done using any algorithm such as naive-Bayes algorithm, SVMs are there, convolutional neural network. There are so many algorithms where the training can be done. So that is where after training, that is the training has been done on the data set. We have the trained model ready, which is able to detect each cough sample as pneumonia or non-pneumonia, or maybe tuberculosis, not tuberculosis, or anything else. So here it is just a sample, what I'm showing it here, so that it detects the samples as pneumonia and non-pneumonia samples. So this is one methodology sample. So the description I have told it here, what is about the denoising, what is about the segmentation, where it is we have to detect the start and end points of the cough sounds, we have to do it. So coming to the data sets, what I had talked about, there are a lot of data sets are nothing but the recordings of the patients which are available in some public repositories, such as Kaggle, GitHub, or any other like Stack Overflow or anywhere. It is these are some of the public sources, online, what I can tell, open source sources where we can get the data sets, recordings of the samples, of the cough samples of the patients. So one such data set it is about pneumonia and non-pneumonia, where 82 patients were with the pneumonia were recorded, 91 normal patients recordings were also collected. So then the total duration was about 372 seconds of pneumonia patients, and as it is. Number of cough samples here, it was detected, that is 82 patients, 268 cough samples were taken. And the ratio of male and female is 43 to 39 for pneumonia patients, and the average age of all the samples were 0 to 11 years. As I told, this is a data set only about the kids, so that to detect about pneumonia and non-pneumonia in kids. And this is one more data set where we had around 300 recordings. Average duration was about 9.35 seconds, plus or minus 1.36. And this is another sample, another type of data set it is. So like this, different types of recordings, different data sets are available. We can make use of any of these data sets for training our models. And again, this is just a comparison what I could get it about different disease prediction. Bronchitis, which was trained for the asthma and the chronic pulmonary diseases, or maybe it is using the the second column talks about which algorithm, ML algorithm they had used it. They have used CNN, or maybe it is logistic regression, or maybe it is CNN and RNN. And nowadays the most popular, which is becoming as of now for 2024, if you take for all the cough sounds or maybe the speeches, the best algorithm nowadays they talk about is LSTM, long short-term memory. That is the popular ML algorithm, which is becoming popular for speech recognitions or speech analysis. And about the accuracies of all these works which has happened, this is just in what I can tell, survey I can tell. The accuracies of all the works using all these algorithms for these different types of diseases is been listed here, where the accuracies is around 91%, 89%, and so on, with the sensitivity and specificity. So these are the different accuracies for different works. And as I told, the popular algorithms, you can see it is ANN, one of, according to the 2023 paper, which I've taken this data. I've taken from some of the papers which I have referred it. So continuity of this ANN algorithms nowadays, as I told, CNN, RNN, and LSTM are having the highest accuracy compared to other ML algorithms which are there here. Hidden Markov models is there, or maybe it is RNN is there, KNN, K nearest neighbor, or any such algorithms. So you can easily understand here in this example, like what is the difference between the pneumonia cough signal and the bronchitis cough signal, where the amplitude of this signal, which is plotted across time, you can easily observe, you can easily recognize, I think, the difference in the patterns of these two cough signals. See, for as I told the physicians, it will be very difficult to analyze this. But when these features are extracted, the amplitude and the amplitude in both the signals, when they are extracted, when they are trained, and the models have learned, ML algorithms have helped. So these automations of these detections, it will be very accurate compared to the normal physician analysis. So this is just a comparison of two different types of cough signals who was having pneumonia and bronchitis. Yes. And with all this introduction, simple introduction, what I told, this is a very good field. I think we can work at us, but there are a lot of limitations when we do such ML and IoT integrations for healthcare, especially about the cough respiratory diseases it is. So maybe it is some of the limitations what we have is about the legal duties for infectious disease control, because different geographic boundaries or different cities, different countries will have their own limitations, their own legal procedures will be there. And the low quality of the recordings, when we ask the patients to send the recordings, maybe they collect the recording from a very low mobile devices, or maybe from they'll collect the recording from a noisy environment. So it will be of very low quality. And the reliability of software and hardware is one more limitation. Because we are reliable completely on the ML algorithm, the hardware devices, the IoT devices, what we take the data to. So to rely on those hardware and software is again a limitation for us. Privacy and security issues. the lot of data is being collected from many patients. It is so how secure the data is, how privately that data has been taken. It is to stored. It is so it is again one such limitation, and using the mobile technology, which is having very limited hardware resources, computation power, everything for such detection and diagnosis. Because when we develop an app, usually it will be there on a mobile, and we ask the app to diagnose whether it is a pneumonia or a bronchitis or it is tuberculosis. So using that mobile device, mobile technology, which is having very limited computing power, computing resources. So that is again one limitation what we have, because we have some models which will be of very high size. We have some trained model to be deployed. We have some models to be deployed in an app it is, but it is having very limited resources, battery wise, memory wise, computation wise. So for that, it's again a limitation it is. So like this list, these are some of the limitations what I have listed out in this field of study. And the opportunities which are there with respect to this field are, if the authorities are more involved, maybe it is from the corporation levels, from the city levels, it is from the politician level, if they are involved along with the scientists, doctors, or everything, I think we can have a very wonderful work done. Development of new AI algorithm. There are a lot of AI algorithms nowadays, starting from the decision tree or maybe till to the CNN, RNN, LSTM. But particularly for this type of cough sounds, particularly for these type of respiratory diseases, if we develop better algorithms, I think there is one opportunity what we can do it. The economics of the biotech markets has to be improved. It is one more opportunity which has helped to do a lot of wonders. More secure platforms to store this data, what we get it through IoT devices, the cloud platforms, which has to be secure. See, this is one more opportunity where we have to work with us. The security of the data, what we are storing on the cloud from the IoT device, we are sending it to the cloud. So there are a lot of security challenges, opportunities are there where we can work it. So these are some of the more opportunities are there where we can have a lot of open-ended challenges available, opportunities available to work on this field. Few I have listed it out. So these are some of the opportunities and the limitations, what I can tell. And as I told, the references, I have referred some IEEE papers for this, and the references are this. Just an overview of this entire.
Hello.
Yes, sir.
Any questions from audience? Yeah, I think there are no questions.
Yeah,
Madam,
okay,
thank
sir.
you very much, madam, for your session.
Thank you, sir. Thank you, sir.
On
Thanks
behalf
for
of
the
all the
opportunity,
officials
sir.
on behalf of all the officials of DTE and other participants,
Yes, sir.
thank you once again for your session.
Thank you, sir. Thank you, sir.
So with this, we conclude the session, and we'll meet for the next AROHAN session 15 on 30th September. Thank you very much.